Okay, today we're going to see this systems of equations from the bond graph. We have several forms of those equations. One is the individual constitutive equations, which as a set will produce the differential equations of the entire system. We also have the Cauchy form, which is a simplified version of those where we have only the derivatives and the state variables and the inputs as the only variables on the equation. So we have that form. But there is a third form called state space form, which is derived from that. And we will see all these forms as we go along with this example that you see it on the left-hand side. So the very first thing we're going to do is I'm going to write a set of steps to do this. So why don't we just go here, say steps, okay, to derive equations. The first is we're gonna call it a system of individual equations. System of individual constitutive equations. Okay, so that's the first kind that we will. So what are we going to do to do this? Step number one, write the E's and F's for each bond considering the power flow and the causal marks. Let's do that. So I'm going to leave the right hand side free for the free for these steps, and then I'm gonna use the left here for the derivation. So I'm gonna go e sub 1 first. What's e sub 1? E sub 1 is basically e sub 2, because in here, although it's true power, we left it like this when we build it. In here we have this one junction sets the flow here, or F1 is F2, but also E1 is equal to E sub 2. And we have the source of, the F1 is what? We have SF1 in here. All right, then we have E sub 2. So I'm just going to go by each one. E2 has to be equal to E sub 3 because this bond is the one that determines the effort for this and this. So E2, although E2 is E5, but E3 is the one that caused it. So that's what we wrote it right in here. F sub 3 is also an internal bond in here. F sub 3 is not caused by this one, but rather is F2 minus F sub 5. Okay, and then we have this, let's see, let's move it up a little bit. What we have this, let's go ahead with E sub 3. What's E sub 3 here? This is determined by, and E sub 3 is basically E sub 4. We didn't simplify the graph, although we could have done that. And then F sub 4 is equal to, F sub 4 is F sub 3. But because this is a C element in here, E sub 4 is defined as 1 over C sub 4 Q sub 4. And I am going to change the color to illustrate that in here we get our first differential equation, because you know that based on that C element, that dq sub 4 dt is equal to f sub 4, see? So that's this one. So let's continue on. I'm going to use this space for that so that we don't, so that we can see the bond graph, the equations, and the system at the same time. So why don't we put in here, okay, so I'm just going to draw a line in here. And this is going to be E sub 6. What is E sub 6? E sub 6 is this SE6, and F sub 6 is F7 because this is the one that determines the flow for all the other junctions here. And then we have E sub 7. E sub 7 is E5 plus E6 minus E8. E sub 5 plus E sub 6 minus E8. We are seeing how the efforts add on this one junction. E5 plus E6 minus E8 equals E7. But F sub 7 comes from the integral form of the I element that you have in here, P7 in here, this one. And then the second differential equation comes up. So I'm just going to change colors again and says dp sub 7 dt is going to be equal to E sub 7 is the second or the second differential equation that we have. And then we keep on going. We say E sub 8 now is equal to what? E9. And what is F sub 8? F sub 8 is caused by F sub 7. Yeah. And so I'll just keep using this spacing here. So we go over here. We are on 8, right? We go 9. What about E sub 9? E sub 9 is E10 plus E11. See, what comes in equals to what goes out. So this is E sub 9. Then we have F sub 9 is who goes F9? Not this, but over here, F8 minus F14. Okay, and then you have 10, which you have E10 is equal to 1 over C sub 10 Q sub 10, and that F sub 10 is equal to what? F10 is F9. And from here we have our third differential equation, which is going to be dq sub 10 dt is equal to f sub 10. And I think we only have just a few more to go to get it all done. So we have this, in here we have this for the Q10, 11 is where we want. Whereas E11 is equal to R11 times F11, see? And then we have that E11, F11 is equal to what? F11 is F sub 9. We have a few more to go now. So 12, E12, E12 is equal to SE12. And then we have that F12 is equal to what? F13. Because this F13 determines the flow for all the others in this junction here. And then we have F12 is equal to F13 here, and then we will have E sub 13 is equal to E12 plus E14 like this, and then we have E13. F13 would be 1 over I13. Let me just correct that. I need to write it in here. F13 is 1 over I13 P13 like this, and E13 is equal to what? No, we already wrote that. No, it's dP13 dt is what we need. So I'll just erase this. And then you're gonna have in here, what do we say? This is dP13 dt is equal to E13. See, it's got 4 equations on those ones that I have it on, in red. So now I derive the individual equations. See in the step right, E's and F's for each bond. Consider the power flow and the power flow marks. Here you consider which bond set, or you can say caused the efforts. The efforts. This would be for a zero junction. Consider which bond, and then go with that. Also consider how the flows will add. And at the same time, number 3, I'm going to say consider which bond, or parentheses, you could say set as well, or caused the flows. In one junctions. So consider how the flow will add, and also consider how the efforts add. Consider how the efforts add. How the efforts add. Okay. So now we have 4 equations, and we have done this first set, considering the system of individual constitutive equations. And to do the Cauchy form, what the steps we need to do for that? Here we start with the derivatives and substitute the individual constitutive equations. All right, that's what we're doing. So I am going to write down here the Cauchy form on this, on the bottom one over here. Okay, one thing though, before I did this, I think it would be good to go to my bond graph model and show you how ChemG has these equations inside this bond graph. So to do this, I think I'm going to go on the display mode, go back to the color one. I think we can see it, the contrast is much nicer there. And here we go. But I need some of these equations to be visible. So if I go to the menu that says Analyze, yeah, so let's just go take a picking here. We're having a bit of an issue with the mouse right now. Hold on for a second. Okay, what we're going to do now is to verify that what we wrote in here is in fact what's behind the picture in the computer program. So if you come here and you say Analyze and you say Peak, let's take a look, for example, over here. If you click on this C element in here on number 4, see what it says dq sub 4 dt is f4. That's what I have right here on the left hand side in red. And then E4 is Q4 over 1 over Q4 Q sub 4, which is exactly what I have on the line above. Okay, what about here on this one junction here? Do you see F5 is F7? Go where is the F5? We didn't do F5 or the we have F6 as F7, and then we have E7 is E5 plus E6 minus E8, which is what you have right here on the left, right there. E5 plus E minus E8, and then we have F sub 8 is F7, which is the one on the bottom here. And if you click over here, what you have is the differential equation for the I element. Okay, so we have done these things so far correctly here on this. I think we could move it a little farther down here. Hopefully it still has the mouse, and then we're going to go back over here. All right, so now we have to take these equations and we will have to rewrite this. And so we're going to go over here and over here, and then we're going to write it down. So in here, I am going to write the, how do we get this Cauchy form? Let's just go, there's 4 of them. So what I'm going to do is, let's move it over here. And in here we have this dq sub 4 dt is equal to f sub 4. And then you have this in here, what's f4 if you have in here is f sub 3. And what's f3? It's f2 minus f5. And what's f2 here? Did we do f2? I think we're missing an equation here for f2. Let's just add it, in here f2 is f1. So f sub 2, f2 is f1. From here, f2 is f1. and then you have the minus, what is F5? F5 is, in here F5 is F sub 7. So we're gonna write it here. This would be SF1 minus F7 would be what's in here. See, 1 over I sub 7, P sub 7. Yeah. So just to make sure that we have the equations completely, we added two more for F sub 2 is equal to F sub 7. F sub 2 is equal to F1 is where I wrote, and F5 is F7, and that F sub 5 is equal to F sub 7. So that way we have them all correctly in there. Let's just make sure that that is also right in case we need E2 is equal to E sub 3. No, that one we did have. It's only F2 that we didn't have. So we don't need any to correct it anymore. So we are fine. What about the, are we gonna need E5 though? Yeah, that we do need. We just messed up the sequence on one of them, E sub 3, so that way we are fine. So now we are going to go to the second one. So that's the first equation that we have. I'm going to rewrite it so it would be nice and neat. dq sub 4 dt is going to be equal to SF1 minus 1 over I sub 7 P sub 7. And I'm going to circle this as the first differential equation in the Cauchy form that we have. And we're going to do number 1. And then, remember, there's 4 of these. So the second one that we have is dp sub 7 dt. And this is equal to E sub 7. So let's keep going on doing the substitutions now. And E sub 7 is equal to what? To E5 plus E sub 6 minus E sub 8. And then this would be E sub 5, which is up there. We're going to go as a, no, E5 is E3. We wrote it down there. So this is E sub 3. And then you have E sub 6, which is what? E sub 6 is SE6, right? And then plus E sub 8, which is E9. Yeah. I think perhaps we'll use one more of the spacing here. E sub 3 is E sub 4. Plus E sub 6 is E6 is, yeah, well, let's write it down in there. Say AC6 plus E9 is E10 plus E11. Yeah. So in here you're gonna have, what is E4? 1 over C sub 4 Q sub 4 plus SE6 plus E10, which is E sub 10 is 1 over C sub 10 Q sub 10 from here, and then E11, which is plus R sub 10 times F11, or is R11? What is it in the bond graph? You want to make sure that we don't mess up. It's R11, not R10. Okay, so from all this, the only one that we don't know is this one. We know everything else, so I am going to concentrate on expanding that one and then using to to write the equation in the end in a nice way, because we're going to do some substitutions here to find out what is f9 is. What is f9 is f sub 8 minus f14, right? And what is f sub 8 here is f7, and then f14 we have, did we do f14 or we stop at 13? Oh my goodness, no, we don't have 14. Oh yes, we do. It's this internal one. E14 is E9, right? So we make sure that we're missing this. And F14 is equal to what? To F13. Yes, F13. And then we have F7 minus, no, F14 is F13. And this 7 is, F7 is the one that is up here on the left hand side. You see it there? F7 is 1 over I sub 7 P sub 7 minus 1 over I13 P13. So we have this in here, we will say equals to 1 over C sub 4 Q sub 4 plus SE6 plus 1 over C10 times Q sub 10 plus R11 times this. So it would be R11 over I sub 7 P sub 7 minus R11 over I13 P13, and that is my equation number 3 with 2 dP sub 7 dt. And then we could just put it like this. This is equation number 2.